Hi, I'm Sam. I'm working in the Natural Language Processing team at Health Data Research UK, and today I'm going to be going over a web-based annotation tool called Markup. Firstly, I'll run over what annotation is, what the purpose of annotation is. I'll then go over some of the key challenges that are faced within the annotation process and discuss how Markup attempts to tackle these issues. And finally, I'll give a live demonstration of Markup in action to demonstrate some of the key features that it offers. So annotation is effectively just the process of transforming unstructured data into structured formats. So in the case of text data, you may have an unstructured text document that you would run through, select relevant spans of text within the document. You would associate labels that describe the subset of text yourself using your domain knowledge, and the culmination of that subset of text, along with the labels, would be considered as one annotation. This process would be repeated for the entire document or the entire set of documents. These annotations can then be exported in structured formats that can be used for a wide variety of tasks, such as training machine learning models. So the key challenges within the annotation process primarily come down to the time-intensive nature of it and the domain-specific knowledge that's required. So it's time-intensive because it takes a long time to go through these documents, determine what is a valid span of text to annotate, and determine what are the appropriate labels to apply to that span of text. And those labels, of course, require domain-specific knowledge that few people may have in certain domains. And disagreements will often arise throughout this process, which increase the amount of time required, as those disagreements will often need to be resolved through discussion or debate. So Markup aims to tackle these issues by somewhat automating the process and standardizing it whilst maintaining the high degree of accuracy that's often required. It does this by introducing an active learning model and a sequence-to-sequence model that will analyze the document and predict annotations based on your style of annotation. So it will learn as you annotate and suggest complex annotations to you that include both the span of text to be annotated as well as various labels for that span of text. And Markup also includes a variety, or utilizes a variety of other natural language processing techniques to further speed up the process, as I'll show now in the demonstration. So this is Markup. Right now I've got it running on a local server, which you can do yourself through the open source repository, or you can also use the central website, which is just getmarkup.com. So for those who've never done annotation before, I'm just going to jump straight into the process, and I'll come back later on and go over sort of the configuration and setup details. So if I go to the demo, it'll just open 5 random documents that you can play around with. You'll see a display like this with 3 different panels. On the left, you've got the configuration panel, and here's where you can choose the entity and attributes that make up an annotation, as well as an ontology mapping. And an ontology is basically just an external dictionary of terms. These can be useful to map to in the case that you want to standardize the text that you're annotating. So if the text you're annotating contains misspellings or unconventional wordings, it can be useful to standardize that. The central panel is just the document that's currently open, and the right-hand panel is the annotation panel with both the annotation suggestions that Markup has predicted itself, as well as manual annotations that you've added personally. So if I click on the annotation suggestions, you'll see 3 of them. Right now, Markup's set up to only predict prescription-based annotations, but you can change that as needed based on your domain. If I go ahead and hover over each of these annotations suggestions, it will show it within the document itself. I can then also click on an annotation to see the various attributes that Markup has predicted for that annotation. So in the case of a prescription, Markup will try and predict the drug name, dose, unit, etc., as well as an ontology mapping from the ontology that you provided. You basically have 3 options with each suggestion, so you can either reject it outright, you can accept it outright, or you can edit an attribute if there's just a slight error. So I could change this to 250, accept it, and it gets added as a proper annotation. Annotations can, of course, be exported. Right now, Markup allows you to export into BRAT standoff format, which is accepted in a lot of existing natural language processing tools, such as Gate. And it's also possible to annotate manually, of course, which you just do by highlighting the text that you want to annotate, selecting an appropriate entity, and Markup will then display attributes that relate to that entity. So in the case of prescription, it will only display prescription-based attributes. You can populate these yourself. And you can also define a mapping, an ontology mapping. Markup will do its best to also predict ontology mappings using cosine similarity, but you can always search the ontology directly if need be. So adding that adds a single annotation, and that's the process. As you can have multiple documents open at one time in Markup, you can just navigate between these quite easily, and it will do, Markup will predict as it goes along. So to do the prediction of annotations, Markup uses two models. There's an active learning model and a sequence-to-sequence model. Both of these models have been trained on synthetic data only. And effectively, the document that you've currently got open is cleaned and broken down into sentences. The active learner will then classify sentences to determine whether it's likely that the current sentence contains a target annotation. If it does, that sentence is passed through the sequence-to-sequence model to predict the attributes for that annotation. Those are displayed, and then the user can accept, edit, or reject the annotation suggestion, as I showed earlier. And the feedback from accepting, editing, or rejecting is fed back into the models so that they hopefully improve over time. So if I jump back to the home page, I'll now go over sort of configuration and setup process, but this will be explained in a lot more detail in the documentation, so it's worth going over that. So jumping over to the setup page, there's a basic setup where you can choose between opening a single document or a folder of documents. Opening a single document, you just choose the document that you want to annotate. Right now, this has to be a text document. You also have to choose the configuration file. The configuration file effectively defines the entities that you'll be able to select during the annotation process, as well as the attributes and the mappings between various entities and attributes. Markup offers an inbuilt tool to create these configuration files, which just gives a visual display. There are more advanced options as well when setting up. So you can define an existing annotation file for Markup to a display. You can then go ahead and edit those existing annotations if need be. You can select training data, and this will be used to train both the active learning and the sequence-to-sequence models I talked about earlier. And similarly with the configuration file, Markup offers an inbuilt synthetic data creator. So this uses variables that you can define yourself, either text variables or numerical variable ranges. And you then also need to define sequences, input sequences and target sequences that embed the variables that you've defined. And you can then use those templates to generate any number of distinct examples, synthetic examples. Finally, you can also select an ontology. So Markup provides existing ontologies such as UMLS that you can access, assuming you have the appropriate permissions, or you can provide a custom ontology. And the setup process for using the folder is very similar. You just select the folder and provide training data and the ontology. Thank you for taking the time to listen to this. Please let me know if you have any questions by email.